Good morning, everyone. Today, we'll be presenting the Analog Electronics Midterm Evaluation Project, which is on the topic Water Level Indicator. This has been prepared by my partner, Aman Prakash, and myself, Ansh Jindal, roll number 32. Aman, could you please introduce the topic?
Okay, so the objective of this project would be to build a water level indicator, and we have did this using the Proteus 8 professional software. So we'll be determining the volume of water in an overhead tank or any other water body, and this helps in the prevention of overflow of water. About the working principle, the circuit is designed to indicate four levels of water stored in the tank. That is low but not empty. That's around 20%, almost half 40%, 70%. 70% would be a sufficient amount of water in the tank, and full but not overflowing. So we have set that to 95%. Now, when there is no water in the tank, all the LEDs are switched off as an indication that the tank is completely empty. And when further water level starts to increase, the water acts as a conductor, making the circuit to be a closed one. Hence, the first LED, that is the green LED, will glow indicating that there is water within the tank. Now, as the water starts rising and continues to reach the and reaches the 40%, the second green LED will glow. When it further increases and reaches 70%, the blue LED will glow, and so on. And finally, the red LED, that's 95%. About the methodology.
All right. So the circuit not only indicates the amount of water present in the overhead tank, but also gives an alarm when the tank is full. We've used a buzzer to indicate that the tank is full, so that the user may know that the tank is full, and then he may disconnect the motor, which is filling up the tank. When the tank is empty, the wires in the tank are open circuited, and the 100 ohm resistors pull the switch low. Hence, opening the switch and LEDs are off during this time. As the water starts filling up, first the wire in the tank connected to low indication wire and the positive supply are shorted by water. Now this closes the switch low indication wire and turns the LED 1 on. As the water continues to fill the tank, the LEDs 2, 3, and 4 light up accordingly. When the water is full, the base of the transistor BC548C, which is used in this project, is pulled high by the water and this saturates the transistor, turning the buzzer on.
About the setup. One electrode wire is with a 12-volt battery is placed in the circuit. Next wires are placed step by step above the bottom probe. When the water comes in contact with the electrode tip, a conductive path is established between the sense electrode and the tank wall or reference electrode, which in turn makes the transistors conduct to glow LED and indicate the level of water. About the components involved, we have used the resistor, we have used the BC548C resistor, and then there's a transistor, LED, buzzer, connecting wires, and 12-volt battery.
Well, let us look at the initial open circuit, or we'll just look at the circuit that we have made in the software Proteus. Aman, could you switch over to that in the
Yeah,
software
we'll be
rather?
discussing about this in detail when we simulate it in the Proteus. We'll be doing that.
All right, let us now move on to the features for the water level indicator. One, it is very easy to install. Second, it has very low maintenance cost. Third, it has a compact and elegant design. It also avoids seepage of roofs and walls due to overflowing tanks because the user gets to know about the overflow of water from the tank because of the buzzer that we have placed in the product. It consumes very little energy and is ideal for continuous operation. And it shows clear indication of water levels in the overhead tank.
The need for the water level indicator would be it could solve the overflow problems, to prevent wastage of water, and to prevent wastage of energy. Now, about the
The
applications.
applications in this project are endless, that Aman will tell us about now.
So, the water level indicator circuits are basically used in factories, chemical plants, and electrical substations, and in other liquid storage systems. There are many possible uses for this simple system. Examples include monitoring a sump pit, that is to control pump activation, rainfall detection, and leakage detection. Electronic water level circuits have the capability of alerting if there is a water leak somewhere in the factory. And that's pretty important. And also, when the water level is too high or too low or exceeds the higher limit, it can detect the water level easily by hearing an alarm sound or from different colors of a light bulb. We can also measure the fuel level in motor vehicles and the liquid level containers, which are huge in the companies. Now we'll be discussing about the simulation that's in Proteus. So this is our setup. We have the water tank in here. We've got our 100 ohm resistors, and that's our BC548C transistor, and the LEDs that will be indicating the levels of the water tank. So what happens is that when the water starts to rise, at first there's no water in the tank. So when we try to simulate it, nothing happens. Now, as the water rises, the water acts as a conductor. So once it reaches the 20% mark, this wire connects over here, and water being the conductor, it acts as a connecting wire. So as you can see, when these wires connect to each other, and when we simulate it, the green LED starts to glow. So that indicates that the water has reached 20% of the water tank. Now, Ansh should be talking about rest of it.
Yeah, so as the subsequent wires, the water level rises, the subsequent wire complete the circuit. First, we'll simulate that by connecting the 40% wire to the 20% wire so that it completes the circuit. And now we will see the two LEDs glow up. That was the desired output. Now, when the water level rises further upwards, then 70% wire also gets dipped into the water and completes the circuit. That would mean three LEDs glow up, with the blue one being the third one. Now, finally, the 95% LED glows, in which the fourth LED, the red one, will light up, as well as the buzzer will start to sound, indicated that the circuit is closed and the water level is full, and the user should stop the supply of water.
Now, talking about another, yeah.
That is all for our
Yeah. So
project.
talking
Thank
about,
you.
yeah, yeah. No, we'll be talking about this as well, right?
Yeah, yeah, sorry.
Yeah. I'll start.
Yeah,
So talking about another viable and cost-effective alternative, uh, with all the wires in our circuit, the setup can seem a bit messy. So this could be considered to be an alternative circuit over here. So we have what we have done is that we have installed a float in here in the overhead tank, and it stays afloat when the water starts to fill up the overhead tank. And the float is mounted with a radar liquid sensor which emits IR reflection waves. And hence, the water level of the tank and the depth can be determined. So the sensor measures the distance in a similar way as you have seen in a car when it moves in the reverse direction. If there is an object obstructing its path, the car starts to make a beep or an alarming noise. So the same mechanism works in here. Now, this information from the float is given to a microcontroller as an analog input, and the microcontroller receives the current as input, and it shall be programmed in such a way that it can activate the LEDs and buzzer accordingly. Now, since we're talking about being more friendly, so that it can be installed in homes and other places. So with this circuit, it can one another benefit is that it can be cleaned properly, because with all the wires it will be a messy circuit, and that would be hard. But then with this circuit, we can just move the float apart and then clean the tank or whatever. So that's how this circuit works. And that concludes our project. So yeah, thank you.